Good morning, welcome back to the course. I am Dr. Amandeep Singh and I will take the plant simulation technomatics in this lecture. So, I will again to the start page, view start page. So, we will create a new model and okay. So, this is the model that I am trying to generate here. So, I will just open the class library and open the material flow. So, there are certain objects here, connector, event controller, frame, interface, all these objects are here. So, these objects have specific meaning. This, for instance, this is model frame, this is frame. Frame I can say a kind of a room, one room in a factory. Okay. One room in a factory means a factory in which one kind of specific processes is happening, and I can move to another frame, another room using interface. Okay. So, I will try to first tell you what are these objects. Frame, as I said, this frame is this is to create your simulation models in a frame. So, we create a simulation models in a frame, this is one frame and it is located in the folder models in the class library. Generally frame is located here in the models. Okay. So, this is actually the primary location of the object, but it has been kept here as well sometimes, because if we need to add a new frame we can add it from the material flow, that is the most used class library here. So, the frame serves for the grouping of objects to build hierarchically structured models by inserting any of the built-in objects, any of the built-in objects from these, or any objects that we can design, because we can design our own objects in the software as well. You know, there is a code that is written for this software to design the objects. So, if someone is conversant with the code, he can also design the objects by itself. So, the frames, when we use frames with connectors or plant simulation, it opens the dialog select interface. Interface means from which frame to which frame do you will. So, okay, I will just put the source here. Source is to produce the parts in the sequence which we specify in a sequence table. Source is a starting point or the entry gate, okay, the entry point from where the parts are coming. If the parts are coming in, it has to go out. So, this is a drain. Okay. Source and drain has to be there when we design any layout. Okay. So, similar to source we have drain. So, the drain has a single processing station, it moves the mobile units from the installation after setting up for it and after processing it, it moves it away. So, where does it take it to? We can put an interface here and take it to the other room. Okay. So, one important object here is a single process. What is single process? Single processing unit receives and processes a single mobile unit, that is known as MU, mobile unit. So, single process is one process, any one process. Like I said, in the cellular layout, different operating point processing units were there. Okay. Those processing units can be called as single processes. So, if I right click it and open it, this is the single process. So, I can change the name of the single process. Let me say this single process is maybe milling, okay, milling machine. So, their processing time is there. Processing time is, we can select any of the distributions. I will talk about the distributions also, like the probability distributions are the frequency distribution based upon certain past data that a specific flow follows, the specific kind of a process follows. Okay. The constant means it will constant just take 1 minute. So, it is 1 minute. So, the constant, the format is kept here, it is days, hours, months, seconds and microseconds. Okay. So, this is 1 minute, the default time. If I pick a distribution, uniform distribution, which is also known as rectangular distribution, I will talk about this later, it will ask us to put it in this format, stream, start and stop. So, I will just talk about this later. Let me first pick any processing time. Okay, processing time, setup time, recovery time, then cycle time, these times can be put. Then also we have the availability of this process is 95%, that is for the 5% of the time it would fail, because in actual conditions for the 100% of the time the things are not available. So, for the 5% of time it might fail. We can change the availability depending upon the process we are working on. For instance, if it is an automated machine can be available for the 99% of the time, and if it is some manual operation, let me say it is an operation where human is involved. For instance, it is a counter, okay, at the entry counter where the person is there, person has to take some time off, or it has to take sometimes it takes tea while working, or it eats something, it talk to the person, talk to the other people. So, we can think that in the actual situation the availability of the person is not 100%, but for the 90% of the time it can be available. So, we can vary this as well. We will work on this. We will work on this. I have changed this from 95 to 90. Okay, I have changed this from 95 to 90. Okay, let me kept it default 95 only, and I will just cancel. Let me just try to run a simple model. Then we have anything, any process or any object we have here. If we need to define the flow, that which flow does it follow, whether is it a straight line, U, S, whatever the flow it has to follow, it has to be connected using a connector. So, this is a connector. The very first object here is connector. So, connector is used to connect an object to the other object. So, I have connected source to a single process, and the direction is showing this direction, arrow is showing the flow. Okay. Now, an important point here is event controller. So, whenever we need to model something, we need event controller. So, I can add event controller here, or event controller, you can also, the event controller is just here in the bar, in the tab here. Okay. So, event controller, what does this do? When your modeling needs require it, you can select settings of controlling the simulation run on the tab, and in this event controller, for instance, the settings, in the settings we can say when would the process end. If we do not use event controller, the process would go for infinite time. So, let me try to just put another source here, or not another single process here. Let me consider there are 2, 3 processes. Okay. I will use connector to connect them. Okay. These are now connected. Now, this is the last one is not connected. If I now run this using my event controller, you know, there is a play button for play, button for the start or reset the simulation. Okay, this is fast forward. If I run this, it is running at the fastest speed. You know, it is, what is this time going on? This time, where the cursor is, this time is 200 and over 300 days, these many hours. So, it is running at the fastest speed. Okay. If I stop it here, it has run for 566 days based upon the constant processing time, which was 1 minute for single process 1, and for single process 2 it is 1 minute, if single process 3 again it is 1 minute. If I right click here and open, I can see my throughput here in the type statistics. Okay, in the type statistics. So, it has produced 1440 pieces. Throughput per hour is also given. Throughput complete for 566 days, it has run for 566 days. Okay. So, it has produced 816350, these many number of pieces. Okay. So, I can see the throughput. Now, there is a big flaw in this flow line. We have just connected, we have, one thing is we have placed the drain and process 1, okay, at some position. So, you can see these dots are here, these dots, this is the dot 1, 2, 3, it is kept at about 3 meters away from this. Okay. It is kept at about 3 meters away. You know, when we put the machines in a workshop, there is a span. For instance, in your laboratory, when people are sitting in an office, they span one counter, or not, if it is a one cabin and another cabin, there is a space that is designated for that cabin, minimum space. This is ergonomics. You know, if we talk about plant layout, this is work study, what is the minimum space that has to be kept. So, in case of manufacturing, the space, the distance between two machines, not considering the width of the machine, let us separate, other than the width of the machine, the space between two machines is generally kept from 0.8 meter to like even more than that. Okay. So, so that the workers can move from in between. Okay. So, this is a space in between. I have just kept it at a random point here, a random location here. Now, it is not taking any time for the material to travel from the single process 0 to single process 1. Okay, I will name this, I will open, I will call it process milling, the examples which I picked, apply. Okay. So, this is my single process, I will name it after milling, I can pick drilling. Okay. Okay. So, this is process milling, drilling, and I can pick grinding. Okay. So, what is it doing? It is trying to move from milling to drilling in no time. The time taken in between here, here the time taken by this connector is 0, again the time taken by this connector is 0. The right way to do this is to use some material handling systems. You know, there are certain material handling systems here. We have turntable, we have line is a kind of a conveyor, then we have pick and place robot. Okay. I will try to use these and like to tell you that how do we use these. So, I will just pick line, which is a conveyor, and put it here. Okay. Line, I can just shorten the distance, but I have to make sure that this is connected. Okay, this is connected to process 1, but not connected to process 2. I am deleting, I am just selecting it and pressing my delete button. So, this connector is deleted. So, this line is now connected through, sorry, connector has to connect the line to milling. Okay. I am so sorry for this. Okay. Now, if I right click here and open, I can see the length of the line is 1 meter. Length of the line is 1 meter, that is, and the speed is 1 meter again. What is the speed? I will just let you know. If I put another line here, line is my conveyor. Okay, I will take this connector off first. This connector I am taking off. Delete, yes. Put another line here. Okay, it is connected. Okay, this is connected by itself. So, I will extend this line, or I can specifically put the length. Okay, this, let me say the length of the conveyor is 4.5 meters. Okay, I have put it 4.5 meters. Okay, so 4.5 meters. Actually, the grid is on. Because the grid is on, it will just snap. If you think about know about the snap command, it will just snap the specific point. Now the grid is taken off. Now I can move it at any point. Okay, let us keep the grid on to just to see this. So it will take my mobile units, the units which you could see here. Okay, this entity is a mobile unit, that is one unit is being moved from one point to another. Okay, this mobile unit is moved in a speed that is mentioned on my line, on my conveyor. The speed was, let me say what was the speed. The speed is 1 meter per second. Okay, speed is 1 meter per second. If I try to see this at a lower speed using a event controller, let me say I like to just see that how is simulation running. You can see it is going at 1 meter per second, or I can just do it in real time. It will take actually 1 minute processing, but I wouldn't put it real time. I will put a real time into 10 times. Okay, then apply, back, and OK. Now enter real time into 10 times. So in place of 1 minute, it is taking 6 seconds here. Okay, 6 seconds. It has moved at a speed of 1 meter per second into 10 times. It has moved at a 10 meters per second. Okay. So the capacity of the line is only one piece here. If you can see, capacity is put negative, negative means not more than 1 pieces. I can put the capacity as maybe this line can carry 2 pieces, and distance between mu distance is distance between the mobile units. Mobile units can be just kept like this, or the distance can be served. I can put the distance is 1 meter again. Okay, apply, okay, then back and again run. Now you can see 2 pieces can come on this line. So this is the capability of this software. Now the processing is happening. The green color here means, yeah, you can see the dots here. This is yellow dot, this is green dot. Okay. Green color means processing is happening, and yellow color means it is being blocked. Blocked means that the successive process is doing something. Successive conveyor is completely filled, and the predecessor, that is the our source here, or the entry line 1 is blocked because the successor is waiting, successor is completely filled, and it cannot just transfer it material from one point to, from its own point to the forward process. So if this capacity is 2 now, okay. Restart stupid to button. I will just remove this line, okay, and add another line, because I was to change all the dimensions. I will just try to pick the default values which are there. Okay, I will connect using a connector, and in the event controller, in the settings, I can put the end time, when would my process end here. So it is in the format, this is days, this first 0 is days, second 0 is hours, then this is minutes, this is seconds. So I can put in an 8-hour day, it should be 08:00:00. So my simulation would now end at an 8-hour day if I put apply here. Okay. Now let us run. It is running. Okay. Capacity is 1. It is running in the speed that is mentioned here. Real time into 50. You can see in the real time into 50 time is running. Oh, let me try to run it in the fastest pace. So I can see in the setting that the time is kept 8 hours. Okay. So if I need to see it in a fastest way, so I will just apply and okay. Okay. So let me start. So it has run for 8 hours at the fastest speed. It has run for 8 hours. I can now see the throughput here. Open, type statistics, 4931 pieces. Total throughput is 477 in an 8 hour, 477. Per hour is 59 pieces, and throughput per day is 1431. Okay. So for an 8 hour it is telling this much. Per day it is considering 24-hour day here. Okay. So I can see all this throughput, and I can even see the reports. I can see various charts as well, where like for how much percentage of time the process is blocked, for how much the percent of time for the complete 8-hour day, for how much time my process is blocked or waiting or actual processing, or for how much time the failure has happened in which process, because you know failure is 95%. So at some point of time failure could also happen. So all these things can be seen. For that I need to use resources. Before that, I would like to make you to note that we haven't even yet put anything between the drilling and grinding. There is no material handling system. So I like to put pick and place robot. Okay, pick and place robot. Okay, these are the names. If it is getting a little congested, I can take this off using this command. So delete this connector. Now I will connect using the pick and place robot. Okay. Now pick and place robot would just pick the material from the predecessor, that is this drilling, and put it to the successor, that is the grinding. Okay. How does this work? Let us see. First of all, let me try to reduce the speed, just to make you people appreciate it in a better way and see how the simulation is happening. So it is trying to, now the processing is happening, it will now pick and place. You can see pick and place. Okay. For pick and place robot also we have pick and place. Okay, what are the controls here? Entry, exit. Okay, what are the angles? Angles between drilling and grinding, all those things we can consider here, and various times and failures. If we had this is also 99% failure. If this is MTTR is mean time to repair. This is reliability engineering. In reliability engineering, we have mean time to failure, mean time between failures, mean time to repair. So, if failure happens, if actually the process is failed, that is the completely stop, it takes about 1 minute to repair that. Okay. So, these attributes we can select. So, I will keep it default only. So, it is still running, it has run for 18 minutes and 28 seconds. So, this is pick and place robot. So, what I was talking is that let me put this and the grid on here. So, we can use some resources sometimes, like the workers if they are working on, and the broker is there who is trying to distribute the work to the workers, workplace is there, footpath, work pool is there, like I showed you in the car body manufacturing. Then information flow, if the information has to, the method specifically has to be defined sometimes, the generator, I will explain these objects later. Let me first try to show you a simple flow line. So, this is in user interface, I have a chart. As in user interface means, okay, I will put a report here and I will put a chart here. User interface means anything that the user could see after the process has run for one time. So, if this is, I have a chart here and I try to just drag my processes here, milling, drilling. So, I am just trying to put the processes here. Okay. Now, when I run my process, it will show, you can see this chart, it is different colors are there, working, setting up, waiting, blocked, failed, stopped, pause, unplanned, all these times are there. So, when I run it for the 8-hour day, okay, let me try to run it for an 8-hour day. So, it has run for an 8-hour day. You can now see, based upon the times which are put here, the present times, this process milling is working for about more than 95% of time, okay, and for the rest of the time it is just blocked, because the next process drilling or the next conveyor or line, the line which was kind of a conveyor which is transferring the material from one point to another machine. So, that is trying to block this one. This is also blocked, but this is not blocked, but this is waiting for the material to come. Okay. So, these are working for, I can see the exact times. This is the graph, it is just showing this calibrated graph here. I can see the exact times as well. Using these processes. If I open the process, I have opened the milling process. Now, I can just see the statistics in this process. I can see that for 95% of time, if you see here, 95% of time the machine is working and it is blocked for about 5%. It is 95.5% working and 4.5% blocked, which is represented in this graph as well. Okay. So, let me try one thing. Okay, I will say cancel. Let me try one thing. Let me try to change the failure rate of milling. Failures. Okay, it is working available for the 100% of time. So, I will just change this. I will change this, it is working, that is why none of the failures happen, change it to 80%, okay. For 80% of time it is available, for the 20% of time it might fail. So, let me apply it, okay, and apply and okay. Let me run it again for the 8-hour day. Now, what is the statistics? You know, for the 20% of the time this process has failed, you can see the red color here. For 20% of time it has failed. Okay, so, it was not blocked, because you know, had the failure not been there, it was working for about 95% of time, okay, but 20% is the failure, 20% of failure. So, it has worked completely for 80% of the time, and the previous process it is blocked, because actually this drilling process is blocked, because grinding process was not able to receive that, and this is waiting, this grey color is waiting, because it is not receiving anything from the predecessor, from the milling. Drilling is not receiving anything from milling. Okay. So, this is waiting So, I can see the statistics here. So, I can see the statistics for drilling. You know, it is working for, you can see the graph as well here, it is working for 76% of time, it is waiting for 20% of time, and it is blocked for about 4% of time, okay, 76.6, 19.34, then 4.06. So, this is how broadly I am telling you how the resource, how the information flow we can use, and various kind of material flow, how the simulation can happen. This is just one flow line. I have just picked 3 processes. Okay. This was a very we can say trivial example, but in actual processing we can use the simulation, even we can use simulation experiment. So, before going further, I would like to show you the different objects. So, I am not saving this model, this was just a kind of a demonstration for you people. So, this is connector, I have talked about this, event controller is done, then frame is done, interface is done, source, then drain, single process is one process, parallel process, you know, if I put parallel process and right click here and open, parallel process is when we have exactly same machines. For instance, we have 4 drilling machines of same make, which is having same processing time and same setup time, and what we need not to put the 4 machines in parallel, specifically 4 single processes in parallel. We can pick one parallel process because other parameters are same, the attributes of this specific process is same. So, I can pick one parallel process and put there. So, this in parallel process it is shown in the form of a matrix here. This is x dimension and y dimension. Okay. So, 2 into 2 there are 4 machines and the times are exactly same, processing time for all the 4 machines is constant, that is 1 minute. Okay. Then also I can have, it is a matrix, actually if I put 3 here it would not make it 5, it will make it 6 machines, 3 into 2, it will make a matrix, 3 into 2, 6 machines. What if I need to have the odd number of machines? For instance, I need to have 3 machines. For to have 3 machines, what I will do, I will put it 3 into 1. Now, it will bring 3 machines. Okay. Now, where this parallel process is put, I will just pick an example and I will let you know. Now, for instance, there is one process that is being blocked for maximum number of miles, for it is being blocked for 40% of the time. It is being blocked for 40% of time, that means the next process is taking more time for its processing. Okay. It is taking more time for its processing, or it is taking an extended time. So, this machine has to wait. So, what we can do, we can put, if by other taking considering other aspects, management aspects, if we can put another machine or we can double the capacity of the successive machine. So, it was waiting for the 40% of the time, if we have put 2 machines here in that successive point, now this 40% of time reduced to 0, okay, because now the processing is doubled here. So, in that case we can think of putting parallel processes. Now, what does, when there is a waiting, when there is a blocking, we can think of adding new machines, we can think of then taking a few machines off, and if there is a lot of waiting time, sometimes we can even think of doing some other processes, like I have said in case of the process layout. In case of process layout, we have a specific set of machines in one section, another set of machines in one section. If we see that, if we see the overall machines time and we see in the specific this section, for the 30% of time there is a blockage, or for waiting, I would say for the 30% of time there is a waiting, and we can just consider that 30% of time it is a waiting, we can give them some other job. Okay, some other job could be given. So, if it is kind of a process layout, it would be kind of a batch production or job production. So, in case of batch production, another batch could enter, so that there is no idle time. There is no, actually not exactly no, but the minimum idle time is there. The machines are completely working for the full capacity if possible. So, we can try that in simulation before actually doing in the scheduling, then routing, all those things that we learn in the production planning and control, that can all be done using this simulation. Okay. So, okay, this was just an example. I have just picked a parallel process, I will just delete it. So, assembly is that when we have 2 lines, for instance, this is one line, I can just pick it directly. I have selected everything, Control C and Control V. Okay. Now, if there are two flow lines like this, I am deleting the drain. What I can do, for instance, I am manufacturing nuts and bolts and I then need to assemble them. Nuts are manufactured in flow line 1, then bolts are manufactured in flow line 2, then we are assembling them. We can use assembly in this case. So, I can pick assembly and put it here. Okay, let me take this off, assembly. So, I had to connect this using something, a line has to connect this assembly. I will put it very close to drain. Okay, is it connected? No, it is still to be connected here. Connector would connect the line to assembly and another line. Okay. So, a connector would connect this to this. Already exists this side. Okay, the connection is made. Let me say try to run. Now it has run for the 8-hour day and 2 units are being manufactured. Now this is flow line 1. Okay, this is flow line 1. This is flow line 2 and these are being assembled here. Similar to assembly, we have dismantle section. Dismantle section is when something is manufactured or let me say something come from drain, assembled part come from the drain, we have to dismantle that. For instance, a set of screws come from the source which are just screwed on some component and we have to dismantle them and then have to use them for some other purpose. For that purpose we can dismantle. So, this assembly and dismantle I have just showed 2 flow lines here, but we can have multiple flow lines, like we can have multiple flow lines, different material coming from maybe 10 flow lines and different lines and those are being assembled. Like in the car body manufacturing example that we saw, they were trying to assemble or they were actually trying to put the mirror on, the side mirror on and they were trying to tighten the nuts of the wheels. So, those processings were being done. So, this is dismantle section. Next is pick and place. Pick and place is a kind of a robot, okay, that just picks and places from one place. So, it picks a part up at one station and places onto another station. So, next is store. So, stores the MUs. MUs are mobile units. These are the mobile units. It stores the mobile units. You can define the size of the store by specifying its X and Y dimensions, like how many pieces. For instance, this is a store in between. We can also add the buffer in between. For instance, there is a big blockage of the materials in one side. We can add a buffer in between. Okay, if doesn't have the process doesn't have to wait, we can put a buffer. The buffer capacity would be there. Buffer capacity that it can hold, let me say 100 pieces in a day. So, whenever the next process is free to pick a piece from here, it can pick the piece from the buffer. So, that buffer can be used here. So, just after store, we can have place buffer and buffer. Okay. Store is a kind of a long time storage. So, you can see this is the capacity 3 into 3, 9 pieces can be stored here. Okay. I can just change the capacity to the number which I like, not which I like, which is actually required in the process. So, this is store, I am deleting this one. So, place buffer, what is place buffer? This command place buffer. Place buffer lines up several processing units of the same kind, one after the other. The processing units are connected and the mobile units have to be processed at each station, thus they cannot pass each other. A mobile unit may only leave the place buffer after it has reached the processing station with the highest number. So, a buffer with a great capacity that requires high performance, we can use buffer like I said. Okay. So, place buffer is a small thing. The big buffer is a buffer is placed between two plant components that certain purposes. It temporarily holds parts when the following components fail. Okay, when the successor is not able to receive the component. The second function it does, important function it does is it passes the part on when the preceding components stop working. So, it goes there. The dimensions of a buffer with large enough capacity for covering all failures leads to complete decoupling of the plant and the other attributes as well. So next is sorter. Sorter, as the name suggests, a sorter arranges the mobile units by sorting the criteria we define. We can define the criteria. Okay, for instance, if I am having a nut and bolt assembly, okay, there are nuts being manufactured and bolts being manufactured, and on one bolt I am trying to assemble 2 nuts on it. Okay, so the sorter, what the sorter can do, it can pick one nut, or from the bolt line it can pick one bolt, or it can sort it through the different lines. So a sorter, we have to define the criteria, it can do that. So line is a kind of a conveyor. So to draw the straight line with active drawing color, we select this, then this is used, I have just used it extensively in this example. Then is angular converter. So what is angular converter? Angular converter changes the conveying direction of the mobile objects from lengthwise to crosswise. It is a 90-degree. Okay, I can just put it here, angular converter. So you can say entry length, entry speed, exit speed. So it is a 90-degree when there is a, for instance, we need to have the kind of a U type of layout. U type of layout would be like this. U. You will have this direction, this direction, this direction. At this turn, when we need to have turn, we can use this angular converter. It will convert from one line to the cross sides. You know, this direction is 90-degree here. So angular converter moves the parts to its successor within the flow of measurements, like it moves the part onto the first leg of the angular converter. When the booking point length has reached the entrance, then angular converter, the part drives along the entry length and entry speed. All those things we can control. Okay, entry point, entry speed, exit point, these things can be controlled. Okay, like I just showed the attributes of this specific object. Now next is converter. Now what is converter? Converter is intended for modeling material handling equipment. When the part moves onto the converter, it either passes straight through the conveying direction, or it is lifted onto a laterally moving transport level, okay, by lifting mechanism, and then conveyed laterally to the left or laterally to the right. So angular converter was just one thing, it just convert direction from one direction, like 90-degree, it can just convert 90-degree. So a converter we can pick whether to go straight or whether to change the direction, so it can work in that way. So turntable serves for modeling a rotating platform. It is a rotating platform which turns a part around and moves on to the several connecting material flow objects. Turntable, if similar to turntable, we can have turn plate. Okay, I'll just try to put a turntable here. I'll delete this pick and place robot and try to put a turntable here. Now how does this turntable work? You will see. First of all, let me fix this. Oh, it is connected, sorry. Turntable, I need to put the connector. Okay, I need to put the connector here. I am just showing you some examples in between. Why is not being placed here? Okay, let me switch off the grid. Now it will work. Okay, now let me try to run it. Okay, it is running at the fastest pace. Let me try to slow it down and then try to see how the turntable works. Okay, it is now moving at some speed, the speed that is defined. Now processing would happen. A turntable would take it from one place and turn it to the other place. Okay. Now what happens, sometimes we have to swap the workpieces, this workpiece on this side, this workpiece on this side. So turntable, what it does, it just picks the pieces from this point and just swap it like this. Okay. Similar to turntable, we can have turn plate. We can just put one piece on each direction in turntable. It is a single direction turntable that is being shown in the screen. Turn plate, we can have one plate and we can have multiple workpieces put on there. It is like a kind of a rotating dining table that we have. Okay, we put the dishes over there and we can rotate it. Okay, we can pick whatever workpiece we like from in between. So next is turn plate, it is done. Next is track. So, track can be used to model a part of a transport line with or without automated routing, on which the transporter moves the parts. For example, to utilize both the automated guided vehicle system and the model, we can use this track. So, the distance which the transporter has to travel on the track is defined by track's length. The track's length can be defined, then the transporter's mobile unit length can be defined, that speed can be defined. So, the maximum capacity of the track is defined by its length, and the lengths on the individual transporters moving on it can also be defined. That is, the track that is 3 meters long accepts 3 transporters of 1 meter each. So, this can be certain other capacities. So, we can have certain kinds of track. We can even have 2-lane track. 2-lane track is, 1-lane track is only in only one direction. 2-lane track is, it can go in one direction and come back from the other side. It is a kind of a two-way road that we have, two-way track can be put in. Then flow control. What is flow control? Flow control allows the model common strategies for splitting up and for bringing together the flow of materials. It is important to note that the flow control does not possess the mobile units, it only distributes them among the objects. So, flow control is like, it does not store any mobile unit. Flow control is, for instance, I am having a central O here, okay, an O kind of layout, and there are certain lines here, okay. So, what flow control can do, it can just control that, okay, one piece here, another piece here, second piece here, third piece here, it can just control the flow. Whatever line, this is my O, there are lines external to this, okay. The flow control, if I put in there, it can control which of the line is requiring my material now, okay. So, it can control the flow in that way. So, after that we have cycle. So, I just cannot show you the actual demonstration for all the objects here, because in a 2-hour time we cannot just discuss all these things. So, I am just giving you important objects here. I will come to resources here. Resources next is workplace. If we need to work with the workers, we need to put the workplace here. For instance, in place of this line, I can use workers to transfer the material from process milling to process drilling. So, where the worker has to work would be workplace, okay. If some worker simulation has to be induced, some work is there, that is we are just taking the processing time, okay. The machine is automated, it is taking 1 minute processing time, we are just considering it here. If the worker has to work here, and the worker skill, the worker capacity, the ideal worker time and the normal worker time, those things are to be considered, then this workplace is to be put there. Between the workplace, we need to put footpath. You can see the footpath here. I am picking footpath from here and putting here, okay. Workers have to travel through this footpath, okay. To model with worker, we need to have a broker as well who would distribute the work to our workers. Then we need to have okay, exporter as well, okay. So, we can work with the workers as well. I will just show you the certain examples here. So, I am just deleting these one. Delete and delete. So, some important points here, method I have said, then card file, stack file. This is the information flow. How the information will flow, we can define the attributes here and see how the information could flow. Some of the information flow objects could be method, like then we have variable. Variable is when we can work on the source code. If I am saying that we can make our own objects if we can understand the code there. So, there we can add a variable. So, this variable we can declare a local variable anywhere within the source code. So, then we can start to declare our own variable with a keyword. Let me say the one of the variable is known as maybe integer or track 1, track 2. We can name them anything like we like. Then we have table file. Table file is a list with 2 or more columns. It is a kind of a table like the normal table we have. So, we can access the individual cells by employing their index, that is by their position. For instance, the cell number 31, cell number 32, that they can be accessed. Then we have card file. Card file is a list with 1 column providing random access to the contents of the individual cells using their position, that is row number, or imagine the card file as a file card box, we can think of that. So, there are certain things like this. So, next we have user interface. In user interface we can have comment, we can put some comments, we can chart. I have just shown you. Report is the complete report. When we run the complete simulation, I can publish the report of the simulation as well. If I apply and try to run it, okay, it is run it for 8 hours day. So, in report we can publish the complete report. In the complete report we can have just the list of these machines, different machines. Okay, if I just show my comments here, the machines milling 1, all the charts that I have just seen, those can be put in there. For the times for which the machines were working, those can be seen in the report. All these things can be produced. So, next okay, these mobile units are there. Mobile units, the units which are being used are entity. If I this name, this yellow PCs, these are entity. Okay. So, similar to entity we have a container. Container has a capacity. For instance, from the conveyor we are not taking one mobile unit, a conveyor is taking a container which is containing a few mobile units or few entities actually. So, this entity here, the entity is just a block, just a box. Okay. This is a kind of a box here showing here. The entity can be the car that we have just saw in the car body simulation model. So, then container is a transporter is there. So, in place of container, the transporter, sometimes the conveyor is fixed, but the transporter is a kind of a small trolley which has some capacity. So, in this we can just put the pieces and take them along. So, then we have tools here. Tools is bottleneck analyzer. Some bottleneck analyzer, like we have just visualized the bottleneck in the charts, in the example that we have just seen here. But bottleneck analyzer is also there, that will show, okay, this is the primary bottleneck, this is another bottleneck. So, first work on this, those things, or those all things can be done. Then experiment manager. So, I will pick one of these bottleneck. Okay, I will pick experiment manager. So, and try to explain you certain simulation. Okay. So, these are the some of the tools which are used in this software. These are some of the objects. So, now I will try to pick some examples and try to explain you how do we use certain tools. Now, these tools are just to design the process. Okay, the material flow tools are just to design the layout. Okay. Then important tools, resources, I have just tell you, resources are just the workers or exporter, broker which are used. The information flow, how do we use the information? Okay. Then the tools which I have said, experiment manager, what does experiment manager do? It can simulate a specific process, the various you can say box plots, or we can have the simulation and the depth of simulation, those things are going to be done. Okay. So, I like to stop here and thank you for being in the course. So, we will meet next time. Thank you.